of discontinuity somewhere in the middle, right? The point of discontinuity doesn't necessarily occur at one of the endpoints of the interval. So let's see. The third case here would be say if f is discontinuous at C, where C is in between A and B, and it's otherwise continuous at every other point on the interval from A to B. So just this one point of discontinuity at C. So if you imagine, okay, here's my interval from A to B. C is where my vertical asymptote occurs. We could have something like this, right? So what it amounts to is just breaking it up at C into two separate integrals and then doing each of them separately according to how we did in the first two cases. So you would look at them separately here. So then the integral from A to B is the integral from A to C plus the integral from C to B, okay, where each of these now is like the previous two cases. Right, since here from A to C, you see that the vertical asymptote now occurs at the right endpoint, right, if I'm integrating from A to C. And then integrating from C to B, we see now the vertical asymptote occurs at the left endpoint. And so then it just comes back to those first two cases. So we can do this, then this integral can be split up this way, provided that these two integrals are convergent. If one of them is convergent and the other one is not convergent, we say overall the whole thing must be divergent, right? So if either one of those integrals is divergent, the whole integral is divergent. So here, let's look at some examples now. So where does this function have a discontinuity? Yeah, notice that when x is 4, you're going to get 0 in the denominator. So it has a point of discontinuity at the right endpoint here at x equals 4. Right? Otherwise, it's continuous for all the other values in between 2 and 4, just not at the right endpoint there. So it's discontinuous at x equals 4, but it's continuous everywhere else. On the interval 4, not including 4. This is continuous everywhere else on that interval, just not at the endpoint. So since it's just the endpoint that we're given the point of discontinuity, we'll write this as the limit as t approaches 4, approaching 4 from the right or from the left here. From below or above? From below, right? It's an upper limit, so you can only approach it from below, right? So we're approaching it from the left. Integral from 2 to t. So how do I do this integral now? Do I need to do something crazy here? Just a normal u sub, right? I don't need to use a trig sub. Right? It's not an x squared there, so we don't need to use a trig sub. So just a simple u sub. U equals to 4 minus x, so du is negative dx. Limits as t approaches 4 from the left, and so this will be, well, we'll have a negative out in front from the negative dx there, so put a negative out in front. We'll mix that up with a negative on the 4, right, 4 from the left. We got 1 over square root of u du. Now I should also switch my limits of integration since we're doing a substitution. Right, so when x is 2, we get u is 2, right? 4 minus 2, u is 2. When x is t, then we get u equals 4 minus t, right? So I'm just going to literally replace u with the whole expression, 4 minus t. Okay? So just shove it in there. And 2 stays 2. Okay? So yeah, don't forget that. Don't screw that up. So we're replacing t with something now in terms of u, in terms of the new variable. So switch your limits of integration there, right, when you're changing the variable. So that just saves me the hassle of having to figure it out later, which is what people like to do for some reason. They would rather not do this, but then they screw it up later. So I'd rather you do it the way that you find annoying, but not screw it up later. So if it annoys you, that doesn't bother me. So basically, okay, so now we've got a nice easy integral, the integral of u to the half, right? Or sorry, u to the negative half. Add 1, you get a power of positive 1/2. Divide by 1/2, so you have 2u to the 1/2 power. And now we can evaluate it from 2 to 4 minus t. And what happens now when I evaluate it as t approaches 4? So I can plug in 4 now, this becomes 0, right? Question? What happened to the negative? Oh yeah, I dropped the negative, huh? That becomes minus, that becomes a plus, right? And yeah, so now we're just left with 2 radical 2s. So yeah, pay attention to the substitution thing. I think a lot of people forget that, right? So yeah, this is one where we see it's convergent. one, the integral from 0 to 1 of 1 over x squared. So where does this one have a discontinuity? At 0, right? Since right, you see it's undivided 0. So discontinuous at the left endpoint now. So we're going to write this as the limit as t approaches 0